Alright people, welcome back. So in today's episode we're dealing with the first problem of a new section of the dynamic programming journey, which is called on strings. So today we're dealing with problem number 5, longest palindromic substring, which is a medium problem. So let's see what this problem is about. So given a string S, return the longest palindromic substring. A string is palindromic if it reads the same forward and backward. Okay. So for example, BABAD, the output is BAB or ABA, okay, because this is also a valid answer. While in example 2, it's CBBD, the output is BB, okay. So the length of S, which is the string, okay, it's constrained, it's at least 1, which is good, consists of only digits and English letters. Okay, just a few random ideas that come to my mind at the moment. First of all, like if S consists of one digit, like just one letter, like A as a letter is a palindrome. This is the point, okay? And of course, if I have just two letters, no, this is not a palindrome, but this is a palindrome, okay? Okay, good. And then of course we can have palindromes of length 3, 4, 5, 6, and so on and so forth. Now, we want to return the longest palindromic substring, okay? So the most trivial way to do that, I think, is to basically take the string and then, so it's to calculate all the possible strings and then calculate if they are palindromes or not. So I don't even know how to do that. Of course, this is not the best way to do that, but in principle, how one would do that. So for example, let's write down a random strings like A, B. Okay, let's do B, A, B, A, D. So I simply do a double for loop to get to all the possible substrings. And then once I have all the possible substrings, I check like for each possible substring that I have to save. So it would be memory-wise O(n) squared, something like that. And then for each string, I check if it is a palindrome. And if it is, I compute the length. To compute if a string is a palindrome, I need, what do I need? Like, for example, suppose that I have this string BABAD and I need to check it. I take the first letter and the second. I check if they are equal. If they are, I go to the next ones until I'm left with just 1 or 0, okay, in case it is even. And this would take O(n) as total. I do that with O(n), like I do that with n squared strings. So basically the total would be O(n) cube. Okay, the trivial solution would be O(n) cube. But this is of course not what we want to do. So my idea is that, for example, like if you want to check if something is a palindrome or not, you have to check, for example, you want to show that BABAD is a palindrome, then you have to show that B and D are the same letter, then A, and then B is at the center, so it doesn't count. So there are actually two cases, okay? The first case is like the length is even, and the second case is the length is odd. And when I say the length, I mean length of S, of the substring. Okay, this is important because if it is like there are two cases where a string can be palindrome. If it is like even, there is no center. If it is odd, there is a center. Okay, and so my idea is we can take the string. So for example, BABAD, and then say let's see that B is the center. Okay, and then we can expand. So we can say AA. Okay. AA are the same letter, so this is a palindrome ABA. Then we can expand. B and D are the same letter? No. So the longest palindrome that has center in B is ABA. And that's it, basically. Let's try to see if this works. Because if we do that, we have to do that, yes, with every letter. And the expansion may take O(n), but this will be O(n) squared in the end. Right? So let's see what we can do. So let me see how we can code it. So we have to do a for loop. So we must do a for loop like for letter in S. Now maybe it's better to do that for I in range S, and for j in range, not S of course, for in range length of S. And for j in range, maybe it's better to use -1 here. And for, no, without -1. Do we need a j actually? Do we? Probably not. Let me check. So for I in the in range length of S, we need B. We need so we want like something like if I is greater than 0, I is greater than 0, and I is less than length of S -1. No, it doesn't matter. Like here, I have to do a while loop. For I in range ln equal to S, we need to initialize a new value, j equal to I. And then for j greater than, that is crazy. That is so crazy. No, maybe actually it's better to do j is equal to I plus 1 and key is equal to I minus 1, while j is while key is less than is greater than 0 and j is less than the length of S minus 1. Maybe it's better to do greater or equal. So here I can do this, and here I can do this. I can do something like this constraint is needed because I need to check that we are not going like outside of the maximum indexes of the string, and then we want to check whether Sj is equal to S key. If it is the case, then we're done because the length, the max length is let's call it length substring is updated, and it is like we add 2 to the length of the substring, which is initialized at 1, and else we must go outside of the for loop. So we break the while loop, and we also break the for loop once we are outside of the while loop. But before doing that, we take the maximum length as basically the maximum between length substring, here there is a mistake, and the current maximum length. Of course, the maximum length is initialized at 1. So the idea is the following: for every index in the range of the length S. No, I don't need to break the for loop though. I don't need to do that. So for every letter in S, I simply go I center at the value at index I, and then I compute j and key, which are the values at the sides of the, suppose that now we're considering the value A. So now I j and k becomes b and b. I check if they are both of course they are not outside of the index range. Then I check if they are the same. If they are, the length substrings increase by 2. If they are not, the while loop is broken. Okay. Of course, once I do this addition, I must also update key, adding the diminishing key by 1, and I must update j, increasing it by 1, so that you go again to the while loop, you check it again, and you check the condition, and you do that again and again. And then the max length is constantly updated, and then you must return the max length. So let's see if this works. No, it doesn't. The output. Okay. Okay. Sorry, guys. Okay, I didn't read the trace very well, because I must return the longest palindromic substring, not the max length. Okay. So how do we do this actually? Let's do then an if statement, if okay, so instead of calling length substring, we must store the current substring is equal to si, and while key is greater than -1. Okay, if they are equal, then the current substring becomes equal to s that goes from j to key plus 1. This is the new current substring. And but I need to take the length. The length is still there. So the current length is equal to the length, is equal to 1, let's say. Okay. And the current length is updated plus or equal to, okay? And then if max length is less than current length, then I update max length first is update as like the current length. But then I also want to store the current, like the max substring is equal to current substring. And then I return the max substring. Now, of course, we need to initialize the current substring. Okay, it is initialized at this, but I need to initialize max substring. So max substring is initialized at S0. I know that S has a minimum of length 1, so this must be possible every time. And let's see if this is correct. There is an index error in expectation. Expected an intent block after the absolutely guys, don't go crazy, please don't go crazy. So this must be moved here, okay, because this current substring is updated only if the statement is correct. Let's run it again. Okay, now it runs, but the answer is wrong. Oh, the output is nothing. Why is it so? Why the output is nothing? Let me check. So if sj is equal to s key, current, because I'm stupid, I must start at key, so it's better to write it this way so that there is no room for confusion. And then we run it again. Let's see if now it works. And it doesn't. Case 1 works though. Case 1 works though. The second case it doesn't, and that's because of course we're just doing this for the centering in 1 point. We're not considering the even cases. Okay. So here we are just saying for every value, we center the value and then we go again. But of course, like this must be repeated. So what we can do is to simply say, I repeat the for loop again, like literally. I do stuff like for I in range L the length of S minus 1, I define J as, let's say, I plus 1, and key is defined as I, okay? And now, what I do is to initialize the current substring at Si, and the current length as 1. Then, while key is greater or equal than minus 1, and j is less than the length of S, I check if S key and Sj are the same. If they are, the current substring is updated, but this is why it's even. This way, like this time it is even. The current length is increased by the current length here must be 0. Okay, of course, like here there is there is like the current substring I initialized as I, because in principle like the current substring. Yeah, I see the problem. But let's go, like, even though these two lines are actually in contrast to each other, let's see if it works anyway. Because this should work. Yeah, let's see if that, and now it works. Yeah, now it is accepted. Basically, what we are doing is repeating 2 for loops. We basically do the same thing, but the first time we center just in 1 point. The second time we center we consider the couples. So for example, here we start at BB, and we start in the middle of BB. We check if these two are the same. Then we check if C and D are the same, and so on and so forth. Because you see there is a big difference in case we want to check if an even substring is a palindrome, or a not substring is a palindrome. But let's try to submit it. Okay, damn, this works. Okay, this was unexpected. Okay, the point is, this is a long solution. Also, we do basically the same thing. So maybe we can define a function or something to just diminish the number of lines of code. Okay, but then, okay. So guys, here is the policy. The policy that I'm currently applying to the problems we solve is, we don't need clean code. We need code that, we don't need elegant code. We need code that runs with the fastest time complexity or space complexity. So let's focus on that. Here we have a for loop. Here we have a while loop that potentially can go from 0 to the length of S. So this is O(n) squared. This is also O(n) squared. Okay, and I believe that this is the maximum we can do, because of course, the number of substrings are actually n squared. So even like the concept of scanning them all, even that would be on squared. So in the previous case, the trivial solution was on cube. So I believe this is the best we can do. In terms of memory complexity, we are doing O1 because we're not storing a matrix, list, or whatever. So it's O1. However, let me just check quickly if there is a solution on, which is always possible. No, guys. Before looking for on solutions, this solution is not on squared because there is this guy. Okay, which is a bit problematic because this means the entire solution is on cube. Because this guy is not O1, of course. This guy is On. This guy is On, of course. Okay, but this invalidates completely the solution, or can we just find a way to avoid using the slicing? Okay, we can do that at the end. So we can cancel this, and then we can just store the current length. But of course, we need what do we need? We need to take trace of the indexes. So let's say for example we start with start index, and this of course is equal to what? This is equal to 0, right? The first start index. Yes. But then every time we find a new like a substring, then the start index must be equal to key minus 1, because we decreased it, but we didn't pass the condition, right? So key minus 1, and then that's it, and they should be the same in here. So here this is not there, and if start index is equal to key minus 1, and that's it. I return, instead of returning max substring, okay, sure, I need to, so my idea is to not compute the max substring, never, basically, never, and compute that just in the end. So you basically don't compute the maximum substring, never, even here. And then you just do max, what you return is basically S, and then you start at key, now you start at start index, and you must, the maximum length. So you can do something like start index plus maximum length, right? Let's see. No, it's not good. Okay, the output is nothing. Fantastic. Why? That's because I want key plus 1, not minus 1. That's probably because of that. Let's try. All right, fantastic. That's incredible that it works. Okay, and this must be on squared, right? This must be an on squared because there is no slicing anymore. Yes, let's submit it. Okay, fantastic. Okay. So what I was saying before is that my idea, my policy with this problem is we want to decrease the time complexity. We don't want to make it more elegant. So now the only point that matters is, can we make this solution on in terms of time complexity? And the answer is yes, but no, in the sense that apparently there is this Manasher algorithm which is able to solve this problem in on time complexity, but it's basically something that you just study, and you can't basically get that. Like it's very not intuitive, and therefore I don't think it's useful for us. Like it's interesting. It's something that can be interesting, and I would be curious to study it. But I don't think that like solving a LeetCode, you should aim to find Manasher, I don't know exactly the pronunciation, algorithm. So I think it's good to stop here. So thank you very much, guys, for watching this video, and see you in the next episode.